Hello viewers, today we're going to be covering alkali metals. So basically, in the periodic table, the first group is what we classify as alkali metals. So all you gotta do is to just identify the first group by the Roman numeral here. And all the elements classified under this group are called alkali metals. Alright, so basically one thing you can find in relation with all these elements in group 1 is that they all contain one valence electron. Alright, so if we take a look at the electronic structure of a few examples, all the elements in group 1 except for francium, you'll find out that the valence shell contains only one electron. Yeah, so that's a similarity we can see. Alright, also another trend you can see that when you go down the group, the number of electron shells increase. Like you see here, lithium has 2 shells, sodium has 3 shells, potassium has 4, rubidium has 5, and cesium has 6. So as you go down the group, the electron shells increase, so therefore the atomic radii will also increase. So the atom will get from big to bigger to bigger to bigger. Yeah. Alright, so now let's take a look at the melting point here of these group 1 metals. You can take a look at the boiling point, but for this video we're going to take a look at the melting point. Now lithium, my man over here, it has a melting point of 180.5 degrees Celsius. Now sodium has 97.8, potassium going to 63.5 degrees Celsius, rubidium just decreasing to 39.5, and cesium 28.4, and francium 27 degrees Celsius. So a trend you can see again that as we go down the group, the melting point also decreases. This is the same for the boiling point. So a little insight here, we know that when something has a low melting point or boiling point in metals here, we're talking about the electrostatic forces of attractions being weaker. So therefore, less energy will be required to overcome these forces. And the energy is referring to things like heat energy. So therefore, that results in the melting and boiling point. So here we have a diagram of some alkali metals. So we got lithium, sodium, potassium, skip a few, and we got francium. So as we go down the group, like we said just now and established, the number of shells increase, right? So detail you can make out here is that the valence electron gets further and further away from the nucleus as we go down the group. So over here we've made a summary. Since the valence electron gets further and further away from the nucleus, the electrostatic forces of attraction between the nucleus and the valence electron gets weaker. Now why is this so? Like, let's just say this electron is here, and it's obviously nearer to this nucleus, which contains the protons, which is what's attracting it. So therefore, the forces are going to be stronger because they're nearer to each other. But let's just say we take a look at francium here. Your valence electron is so far away, but your nucleus is all the way here, and comparatively, the distance is further. So therefore, your electrostatic forces are bound to be weaker, so it will be easier to overcome. Yeah, so because of this, as we go down the group, the atom is it'll be easier for the atom to lose their valence electrons. So if we compare like sodium to francium will lose their valence electron more easily. So to close this video, I'm just going to talk about the physical and chemical properties of alkali metals. So physical properties of alkali metals, most of them not most of them, they are usually shiny unless they oxidize. They're quite soft actually, and compared to other metals from the periodic table, they have quite a low melting and boiling point. Now when it comes to chemical properties, alkali metals are actually very, very reactive. So they react with cold water to form a metal hydroxide, and as we know, metal hydroxides are basic, so they form a pH of 7 and above, and they also liberate hydrogen gas. So to end this off, I got a question for you. So with this data from this video, could you tell me, out of all the elements in group 1, which element is the most reactive? You can tell me in the comment section below. Thank you.